Alright, you ready?
Yes.
So, top left, intermediate value theorem. Oh wait, hold on, let's do the other side first. Definite limit versus indefinite limit. Okay, do you remember the difference? Definite is when your limit is approaching a number. Indefinite is when your limit's going to infinity. Okay? So if I have the limit as x approaches a equal to f of x, that means that both the left limit and the right limit had to both be equal to L. So then x approaching a from the left is L, and the limit as x approaches a from the right is L. A from the left and then a from the right. So if my limit approaching a exists, the left and the right side both had to equal that same value. Yes? L is just like a number. I just picked L for limit. But it would be whatever your y value is, as long as they match, you have a limit. Now, what if you have an indefinite limit going to infinity or to negative infinity? What do you do for those? Bobo, Botan, Betsy. Or some of y'all do Bed-C. That's fine. Doesn't matter. Okay, now, I'm not going to write what those stand for because you should know it, but if you would like to add those in later, that's totally fine. Okay? Now, what two types of functions do you have to watch out for? Where the limits to infinity and negative infinity aren't the same. Two types. Exponentials. Do you remember the other one? Absolute value. Very good. So, watch out for exponentials. Limit x approach negative infinity. Bless you. Turn into fractions. And then absolute value. Your limit to negative infinity is the opposite of the limit to infinity. Okay? So remember, those are the two you have to watch out for. Exponentials can turn into fractions on you, and then your limits for absolute value approach opposite. So if one side's a half, the other side's negative a half. Good? Okay, one other thing that I didn't really leave room for because I forgot is the order of size. So what is the biggest type of function? Exponentials. What is the next biggest? I'll give you choices. Sine and cosine, power, or log. I'll just give you the list. So sine and cosine are the smallest, then logs, then power, then exponential. So sine and cosine, also constants, that fits with sine and cosine. Okay, constants in sine and cosine, those are all the weakest. Your logs and ln's, those all go next, then power, then exponential. Good so far? Okay, bottom left, we are going to put the definition of continuity. It has 3 parts. Continuity. Okay, what is the first thing that you check to see if a graph is continuous? F of A, very good. Now, F of A has to be defined. So if f of a is 3, that's defined. F of a is 10, that counts as defined. As long as you get a number, you're going to have a y value. That's the first thing you check. The second thing that you check, the limit as x approaches a from the left, and the limit as x approaches a from the right. Those have to match each other. If those match each other, then I have a limit. So I have a y value in part 1. I have a limit in part 2. In part 3, those had to be what? Equal. Good. So f of a has to equal whatever the limit is as x approaches a. If that is true, ... therefore, f is continuous at a. Okay. So a is the x value that you're checking to see if it's continuous. Okay, last thing, bottom right corner, we're going to draw the 3 types of discontinuities. Discontinuities are the places you'd have to pick up your pencil while you're drawing the graph. The first one looks like this. Do you remember what it's called? Besides a hole. Give me the more fancy name. Anybody? R. E. Removable? Have I used that with you? Oh. Oops. Not that important, but the fancy way of saying a hole is a removable discontinuity, because it's basically a function, but that one point is removed. Okay, so your fancy way of saying that would be removable discontinuity. Okay, the second type, maybe I forgot to tell you all this one, we'll see. Remember what that one's called? Oh, someone whispered it, I think. Jump. A jump discontinuity. And what that means is that both of your sides have limits, but they're just not the same. So maybe one side's going to 3, one side's going to 2. You have a jump in the graph from one graph to the other. And then the last type is when you have an asymptote. So we'll say that as our graph's getting closer to that line that have an asymptote, that's called an infinite discontinuity, because your graph is going to infinity. But remember that for all 3 of those, only one of them does the limit still exist for. Which one? The whole. Very good. Okay, when you're ready, turn your paper over. We have 2 more boxes. And then we're going to work on your review. Are we ready to turn? Good. Okay. Oh, there you go. Good, good. Okay. If you need to see it, I'll happily give it to you after we're done. Okay, next box is going to be IVT, or Intermediate Value Theorem. Okay, now it could be confusing that this one has also 3 parts, just like continuity, but you get to use this sheet on your test. That's the whole point of us making it. So what is the first thing you have to check in order to use intermediate value theorem that we learned yesterday? Okay, f must be continuous on a to b. Technically, those should be brackets because you have to have an f of a and an f of b. So first thing you check, your graph has to be connected. Step number 2, what do you have to check with your y values? They cannot be the same. They cannot be equal. Very good. So you'll find f of b, find f of a, make sure they don't match each other. Now, why can't they match each other? Where does k have to be?
In between.
In between them. So my third thing is that the k, which is a y value, must be between f of a and f of b. So whatever y value I want, usually we call that k in the theorem, whatever that y value is, it has to be between my endpoints for this theorem to promise that it's going to happen. Okay, then we're going to write the conclusion with all the symbols. Okay, there must exist an x equals c within a to b such that f of c equals k. If you would like to later pull out your notes and write what each of those symbols means in words, that's totally fine. Okay? Now, if you are asked to find k, if you need to find c value, what do? Do you remember? Yeah, just set it equal to the number you want, solve for when it happens. So if you need to find it, set f of x equal to your k value and solve. And you shouldn't have any weird curveballs on that. Anything you're asked to solve there, you should already know how to do from pre-cal, algebra 2, and algebra 1. But you would take your equation, set it equal to the value they want it to equal, and then solve. Now, one other thing, where would your answer have to be between? Do you remember?
Oh, yeah.
Has to be between the a and b, the x values. Good? Okay, last box. Okay, you ready? Okay, we're going to put the strategies for limits. Limit strategies. What is the first thing that you should try if you are trying to find a limit as x approaches, let's say, 3? What would you do at 3? Plug it in. So, number one, first strategy is you're going to try substitution. Now, what if it gives you a divide by 0? That's when you're going to have to fix it. So if I try to plug in x approaching 3 and it gives me divide by 0, what else could I try? Factor cancel. And then remember, after the terms cancel out, I try to substitute again. So factor cancel and then try to substitute again. If that doesn't work, you could have to do some kind of simplifying. And I'm going to put in parentheses behind that conjugate. Okay, that could involve using a conjugate. It could also be like if you have a tangent, you can split it up into sine and cosine and stuff just kind of cancels. Okay, the last one is you had two special cases. We're going to write them both down on your sheet so that you have them. Special case number 1. The limit as x approaches 0 of sine ax over bx. What does that go to?
A over B.
A over b. And then your other special one was the limit as x approaches 0 of 1 minus cosine x over x. And that one goes to 0. Okay? So this one you would think doesn't exist because when I plug in 0, I get 0 on the bottom, but really it does. A over b. That one you would think it's a DNE because nothing cancels, but it actually does exist. Good?
Yep.
Store it carefully. Get out your review, and we're just going to go through whatever questions you guys have. You can work independently if you don't have any questions. Sure. Once they're done copying, then I'll give it to you. Okay, anybody gone yesterday that needs a review? No? Anybody still looking at this?
That need to be used for both.
Okay. Review's out. Let's look just at first page. Any questions? We kind of did that one yesterday. Anything we need to check? Are they your AirPods? Uh-huh. Why are you selling them? Are they broken? Oh. Okay, nothing on the first page. Second page, questions?
Wait. I have a question.
Yeah,
What do the asterisks on the numbers mean?
they just mean I thought they were hard.
Oh, okay.
So do we want to do the 2 with asterisks? Okay. Yeah, I always try to put like stars on them just so like I know that probably you'll ask about it. Okay, so let's look at 18. Keep your little sheet out. 18 is going to end up being special.
4/3.
Okay, it is going to be 4/3, but you have to kind of reduce it to figure that out. So what is tangent the same as we said? Okay, so this is the limit as x approaches 0 of sine 4x over cosine 4x. So far, so good? Now, what is sine over cosine divided by? 3x. Now, 3x is the same as what? 3x over 1. So if I want to divide by 3x, I'm going to multiply by 1 over 3x. Is everybody good with that? So tan is really sine over cosine. 3x is really 3x over 1, and I'm flipping. Okay, from here, you are going to creatively reorganize so that these little guys get to be friends. Now, why do I want them partnered together? Because that's a special, right? So I can split this up into the limit as x approaches 0 of sine 4x over 3x, and then 1 over cosine 4x. That's allowed. Now, again, why are we trying to do that? Because this guy is special when they're together. So 4 over 3x, what does that chunk go to using your special rule number 1? 4/3. And then what does this go to if I plug in 0? Well, I take x approaching 0, plug it in. 4 times 0 is 0. What's the cosine of 0?
1.
1 over 1, which is 1. So 4/3 times 1 is 4/3. Make sense?
I just, because like, the special case is just.
Yeah, and you have to technically remember there's a cosine in there, but when I plug 0 into cosine, since it stays a 1, you don't have to really do anything extra. Okay? All right, look at 19. That one's almost special, but what's different about 19 compared to special case number 2? What do you notice on the top that they both have? They both have what constant? A 5, right? So I'm going to pull the 5 out to the front, so I'll have the limit as x approaches 0 of 5 times 1 minus cosine x over 2 times x. Now, part of that should look special to you. This is the special chunk. What does that go to? Look back at your cheat sheet if you don't remember. 0. And what's 5 halves multiplied by 0? Still 0. So that one would be 0. So this is special number 1, this is special number 2. And there is one of those on your test, but it's not like the whole thing. Okay, any other ones off of this page? 8 has an asterisk on it. Did y'all figure out how to factor 8? Yes, no? You have not attempted it? Okay. So try number 8. Take a second to do 8. Do y'all know how to factor when you have A's and X's? Or you don't remember? Okay. So number 8, can you factor the bottom of that? Let's just start with that. Okay, this is a difference of squares. It's going to be x plus a and x minus a. On the top, you're going to factor that as per usual rules, but you're just going to put an a in the second term of each binomial. So this is what I mean. At the top, I have 4 times 1 is 4. That's my AC. On the bottom, I need a negative 5. What numbers could I pick? 1 and 4, but I need them to add to minus 5. So turn them both negative. Very good. Then from there, this is the most important step of this. You either have to do the grouping crap, or you can divide them both by 4x and reduce. which is what I prefer, but it doesn't matter. If you like grouping better, do grouping. Okay, from here, I have 4x minus 1. That one can't reduce. And then 4 divided by 4 here, what do I get? Negative 1 over x, right? So it'd be x minus 1. All that you have to do to fix the weird a situation is put an a here and here. So now look, watch. If I were to FOIL this out or multiply it out, 4x times x is 4x squared. Check. 4x times minus a is minus 4ax. Then here I have a minus 1 more ax. That's where the negative 5ax comes from. And then negative a times negative a gives me the plus a squared. So whenever it's a double factoring thing like that, you're just going to put a letter in the front, the other letter in the second spot. Okay, now from there, what do we do? Yep, these guys cross out. And then after that crosses out, what was my limit of x approaching? A. Well, now that the x minus a is gone, I don't get to divide by 0 anymore. I can just plug it in. So on top, I'm going to plug in an a here. I'm going to have 4a minus a. And on bottom, I'm going to have an a plus a. So count up your a's on the top. What's 4a if I take 1a away? 3a. On bottom, what do I have? A plus a is 2a. Can I reduce one more time? They both have a's, and it's 3 over 2. Yeah? I don't think there's one. Okay, so keep in mind, the ones I put stars on are the ones I meant to be hard. We're doing all the hard ones, okay? The whole test, I'd say there's maybe like 2 or 3 hard ones. Most of them are going to be regular things that you've seen before. But you factored that in Algebra 2. Right? Right. Anything else off this page? I love to help. Nothing? Okay, let's turn it. We can always come back. That's not a hand, is it? That's a stretch. Okay. A stretch of excitement. Okay, do we want to do a continuity one? Okay, I put a star on 22, or we could do 21. Okay, what do you do first when you're checking continuity? Pull your sheet out. Continuity is right here. We just did it. Okay, so what's g of 4 for this guy? 6. Okay, then for double I need to check the limit as x approaches 4 from the left, the limit as x approaches 4 from the right. Now, look at the way that your piecewise is structured. Is it a top and bottom type piecewise? No, if it's an x equal to 4 and an x not equal to 4, then this part counts as both x's less than 4 and all of the x's greater than 4. Remember, if it's that type of piecewise, you're plugging your left and right limits both into the same part. Now, can I factor and cancel this? Okay, what am I going to get when I factor the top? Okay, x plus 4, x minus 4. But then I also had an x minus 4 on the bottom. So these guys are going to cross out and just give me x plus 4. Then when I plug in 4 for my x value, what are my left and right limits both? 8. So, part 1, do I have a y value? Yes, it was 6. Part 2, do I have a limit? Yes, it was 8 from both sides. But the third step is those were supposed to be equal, are they? No. So I'd say g of 4 did not equal the limit I got. Therefore what? Yep. Therefore not continuous. Okay. Okay, number 23. If I'm trying to find the limit as x approaches non-breakpoint values, you only plug into that part of the piecewise. So for example, if I was trying to do 23 part A, x is approaching negative 4, where do I plug in? Top or bottom? Negative 4 is less than 0, so I plug in on top only. That'd be negative 4 plus 1, which is negative 3. What if I wanted x to approach 5? What would I do? 5 is greater than 0, so I'd plug into the bottom. 5 squared is 25, plus 1 is 26. When x is approaching 0, what do you have to check? If I don't see the limits on your paper, bless you, you're going to get points off. So you should do the limit as x approaches 0 from the left, and then the limit as x approaches 0 from the right. So when I plug in from the left, I'm plugging into which chunk? The top, right? So 0 plus 1 is 1. When I plug in down here, it's 0 squared plus 1, which is also 1. Then my limit is 1. Now, the only way that you're going to lose points on that is if the limit was DNE and you didn't show the separate sides. So make sure that you're doing that, okay? All right. Turn the page. Any other, yeah?
Wait, but since it's 0, it says, like the bottom where it says 0 is like greater than or equal to.
Yes, so remember, the greater, so when you're doing a limit, you're not checking the equal to. You're only checking a less than is the left side, a greater than is the right side. The equal to only matters when you're checking if it's continuous. And that's where you'd be doing like f of 0. Okay? All right, turn the page. Anything off this guy? Did y'all get 27 and 28? Do 27 if you haven't already. I'll give you, it's a graph, so it shouldn't take long. What was that noise? Noise of excitement, that's what I heard. I love this class. Okay, 27, where does the limit apply? Outside or inside? Inside, so I want the limit as x approaches 1 on f of x. And then I'm going to plug that result into sine. That's what you should be doing. So if I want the limit for f as x approaches 1, what is the y value of the limit? 3. Then it would be the sine of 3. Okay, can you find the sine of 3 by hand? No, you don't have to. Okay, same thing with number 28. Where does the limit apply? To f of x, right? So I'd have the limit as x approaches 2 of f of x. Somebody back there already said it's how big? What's the limit? 2. And then I want the ln of 2. You don't know what it is? Neither do I. That's the answer. Okay, so unless it's like a specific value you should know, you just leave it. Okay? All right, let's jump down to the one right below it, and let's check f. Okay, so you're doing true or false. Says, intermediate value theorem guarantees f of x has to equal 3.5 on the interval from 4 to 6. Okay, what is the first thing you should check? For continuity, oops, I just told you. For IVT, it has to be what kind of function? Continuous. So the first thing I'm going to check is it continuous on 4 to 6? Okay, let's see. Here's 4 to 6. Was it continuous the whole time? Check. Okay, step 2. The y values can't be the same. What is the y value at 4? What is the y value at 6? 4, the y value is what? You're just looking at the graph. 3. What's the y value at 6? 4. Were they not the same? Check. I. Okay, the limit I want, the value I want has to be between them. What's the value I want f of x to equal? 3.5. Is that between 3 and 4? Good. Then can you use the thingy? Yes. 4, 3, and 4. Check. Then it's true. Okay, now you read through G and H. I don't need you to write it out like that, but just follow those same steps. So G says that I'm guaranteed that f has to equal 5 on 4 to 6. True or false? False. false, why?
5 is between 3 and 4.
Good. 5 is not between 3 and 4. So even though the function is continuous and my y values aren't the same, the value I want is not between them. So that's not going to work. Okay, look at H. IVT guarantees that f equals 3.5 from 3 to 6. True or false? False, because why? Okay, if I back up to 3, that's this whole chunk of the graph. And now I have a jump. So that one is not going to work. F is not continuous. F is not continuous at x equals 4. And remember, you wouldn't care if it wasn't continuous at 4 if that wasn't in the middle of your interval. But since that's between 3 and 6, it's a problem. Okay, go ahead and turn the page. 51. Okay, we still have like 10 minutes. Any questions of... Is this the last page? Yes. Okay, want to do one? 31 with the star? Okay, so 31 says find the values that will make it continuous. How do you make it continuous? You got by setting the left and right sides what? Equal at what value? At 2. So you would let k squared minus kt plus 1 equal t squared plus kt plus 2. Then plug in that t is 2, which is your breakpoint. Okay? Now remember, you're plugging 2 in for t, not for k. So give it a shot. I think there are 2 of these on your test tomorrow. So I took my 2 squared and my 2, I combined it to be a plus 6. What do I do now though? Can I cross these out? Yes or no? No, they're not on the same side. When I move this 2k over as a minus, do they still cross out? No, now it's a minus 4k. So they didn't cross out. What do I do next? If I move the 1 across, I still have a k squared. If it's quadratic, you have to factor. So you need everybody together. So I'm not going to move the 1, I'm going to move the 6. So minus 6 here, minus 6 here. What's 1 minus 6? And then you're going to have to factor that. Instead of only getting 1 answer for k, you're going to end up with 2 answers for k. Okay, if I need a negative 5 at the top, minus 4 at the bottom, what are my numbers going to be for 5? 1 times 5. But then which one has to be negative? The 1 or the 5? 5. So 1 times negative 5 is negative 5, but 1 minus 5 is negative 4. Then divide them both by a k and you have your factors. So it's k plus 1 and k minus 5. Now if k is with a plus 1, what is your actual value? Negative 1. And if it's with a minus 5, your value is 5. Make sense? Now the only time you'd have to factor is if your k is squared. That's when you'd have to do that last step. Okay, set up that next one, 32. Okay, you want to make it continuous. What are you doing if you're making it continuous? Set them equal, plug in the breakpoint, which is pi. Very good. Bless you. So I'd have k cosine 12 minus x. Then I'm going to plug in that my x needs to be pi. So I have k cosine pi, 12 minus pi. But cosine of pi, that is a value that you should know. Cosine of pi is what? -1. Good job. And if that's a -1, then what's k now? A negative k. And if negative k is 12 minus pi, then what's positive k? -12 and a plus pi. Or if you wanted to write it like this would have been fine. You could have done 12 minus pi over -1. That's the same. I don't care. Both of those are totally fine. Okay, I probably would have written it this way. But they're really good about the on the AP test about if your answer is the same but just written differently, they'll still give you credit. Okay, last one I did with the other class was 34. Do it? Not do it? You want to do it? Yeah? Okay, so you have f of x. It says, does IVT guarantee that f of x has at least one 0 on the interval from 0 to pi? What is the first thing I check for IVT? What kind of function does it have to be? Continuous. Now, if it's continuous, okay, look at the graph. If it's got a cosine in it, is cosine continuous? Just whoop, whoop, whoop. Yeah, so it's good to go. So, f is continuous. Check. Okay, cosine is continuous everywhere. Okay, what's the second thing I check? Okay, if the y values are the same, so I have to check 0 and pi. Okay, this would be without a calculator. Okay, so f of 0, I'm plugging in right here. I'm going to have a half minus the cosine of 0. What's the cosine of 0, though? 1. So what's a half minus 1? Negative a half. Good? Okay, on the bottom we're plugging in pi. So I'm going to have a half minus the cosine of pi. What's the cosine of pi, though? -1. So if I have a half, minus -1, what's going to happen there if it's a double negative? It's really a plus. So you can put 1.5 like he said, or you could put 3 over 2, just depending on which one you like more. So I have y values. They're not the same. What's the y value that I want it to equal? 0. Now, another word for 0 is a root. If you ever see that, that's the same as a 0. So is 0 between these guys? Yes. 0 is between a half and 3 halves. Okay, now, the reason I put a star on it, or maybe I didn't actually put a star on it, was this part right here. If yes, find the values of C. How do you find the values of C? We wrote it on your cheat sheet. You take the equation, set it equal to what you want. So I'm going to take a half minus cosine x, and what do I want it to be equal to? Good. And how would you solve that? This is find C. What would you do first? Yeah, I'd move the cosine across, probably. So make it a half equals cosine x. And then what I would do from there is look at your hand. If I want one cosine finger, which one do I need to bend? I need one finger on the top. Pi over 3. So I need one finger on top, then that means my answer is pi thirds. Now, question. If your answer is pi thirds, is that between 0 and pi? Yes. So you know that you found a C that's good for the theorem. Good? Okay, it's 48, you got a 51. Any last questions? Good? Okay, so your test is tomorrow and Friday. Fridays will be a little bit shortened because of the pep rally. Your review is not due till Friday. But if you wait to do it until Thursday night, you might bomb tomorrow. Don't do that. Okay? Great job.